I get my Q norm. 5% area, what X value corresponds to 5% area to the left of it. That's what Q norm is. In normal distribution, I do only two things. Either I get the area, if an x-axis value is given, I get an area. If an area is given, I get my x-axis value. That's all. There is the relationship is only between those two. So I get that. Okay. And so I said 85. How do I Q norm? 90, 3. NP and PQ gives me that. So if more than 85% people get cured, I am accepting null hypothesis. So going back to the definition, type 2 error beta is probability of accepting null hypothesis given null hypothesis is really wrong. Okay. I am accepting null hypothesis if more than 85% people get cured. That part is done. Keep it aside. Now, what is given to me that null hypothesis is wrong? If null hypothesis is wrong, alternate hypothesis has to be correct. So I have to now draw my alternate hypothesis. That is based on the evidence that I am seeing. 80% people got cured. 80% people got cured. NP is 80, 100 multiplied by 0.8. Variance is 100 multiplied by 0.8 multiplied by 0.2. So I got some thing. But 80 is my mean. In this distribution, what is the probability of getting more than 85 people getting cured? If this is the reality is actually not 90% people getting cured. That is the null. The reality is that 80% people only get cured. What is the probability that more than 85% people are getting cured? Again, now I get the P norm. This is the area. What is this area? This is the area of accepting null hypothesis. Given null hypothesis is wrong or alternate hypothesis is correct. So that's how we get that. Any questions on that? Just understand acceptance and rejection of null hypothesis. We are only relating to null hypothesis at this point. So acceptance is anything to the right of this value, rejection is anything to the left of this value. That is what I am doing. But there are times when I incorrectly accept that. That is not the entire thing. Incorrectly accepting is, which means I know the reality that null hypothesis is not correct. So this is the correct hypothesis, alternate. What is the probability that I am accepting 90% getting cured? Acceptance of 90% getting cured is only when more than 85% people get cured. So this is the area. Okay? Yes.
Data will be different with each experiment. Each experiment is non-negative.
Yeah.
Alpha is constant reality.
Yes. Beta will change, but then again, if you have done your experiment very nicely, you have taken the sample very correctly, you can't get 80 once and the 30 next time. So it will be somewhere there. So it should not make a big difference. But that's, we are saying a probability because we will never know about the reality. And assuming that everything else has been done correctly, the sampling and everything has been correctly thought out and done nicely, this is the power of this test and the amount of mistakes I can make.
So in the original case that 90% is the mean, how do we know the standard deviation?
Okay, so if 90, it's a binomial, no? 100 people got cured. 100 is n, p is 0.9. So q is 0.1. Variance is npq. Binomial to normal conversion. You can just use the binomial if you want. You can just use the binomial properties.
So what is recalling this?
Recall, there is no scope of doing the recall. Recall will be when you know actually the number of true positives, number of true negatives. But just add to the same thinking. I would rather say what is the probability of true positives. Recall and precision is when we are actually compared with the actual things only. But the question What is the probability? Someone else only answer me. I did not answer. Yeah, who said that? Yeah. So the answer was 1 minus alpha. Again, thinking about it slowly. What is the true positive? Probability of true positive. Did you say true positive or?
True negative.
Yeah. He is asking about true negative. He said true positive, but you figured out that he is asking for true negative.
There is rejecting null recall means no.
Yeah. Recall is, yeah, so let's not even relate to recall part of it. True negative is what we are asking. True positive. What is positive? You only answer me. What is positive? Accepting or rejecting? Rejecting null hypothesis. Probability of rejecting null hypothesis, if it is really, null hypothesis is really to be rejected. Null hypothesis is false. Okay? So null hypothesis is false and you reject it. Where is this? Probability of rejecting null hypothesis. First of all, tell me that part. Rejecting null hypothesis, will it be to the left of this or right? Left. Probability of rejecting null hypothesis. Null hypothesis is 90% people getting cured. Less than 85 get cured, I am rejecting it. Probability of rejecting null hypothesis, when null hypothesis is really wrong. Where is that? Is that the green or the pink? Green. Null hypothesis is really wrong. So this is what is the truth. So probability of rejecting, well, this is the truth. This is the area, 1 minus beta. But what Ashirvan correctly understood, your question is not about that. Your question is about the true positive, true negative. Your question is about the true negative. Negative is what? Accepting null hypothesis. Probability of accepting null hypothesis, given null hypothesis is true. Where will that be? First, probability of accepting null hypothesis. Where is that? To the right of 85. When null hypothesis really is true, which one? Pink one or the green one? Pink one. So this is the one. We will accept this. So this is 95%. Area. 1 minus alpha. We are never interested in that. We are always interested, if we are interested, only in alpha, beta and 1 minus beta. That we have already decided. 95% is normal variation. There is nothing fancy about it.
In this case, alternate hypothesis also 85.0.
Then what will happen? Then what will happen? If alternate hypothesis is 85.08, what will happen? Give me the answer. 50%. That's it. You've given me the answer. So what will happen is 85% people get cured. Your alternate hypothesis, the mean at the alternate hypothesis will be right there. So 50% is to the right, 50% to the left. So 50% will be a beta. A probability of, if alternate hypothesis is 85% people get cured, then mean will be that, variance will be 0.15, 15 times 0.85. So about 13, 12. Square root of that, it will be actually a very small number. You calculate that actually. That will be very narrow. More than that. What is it? Okay, let's do that. If 85% people got cured, that will give you the exercise. Do it. 85% people got cured. Now I want to do the same thing. Not 80%, 85%. So 100 people, P is 0.85. So Q is 0.15. So 85 is my mean. My variance is 100 times, so 85 times 0.15, 12.75. Square root of that? 3.5. So 85 to about 88 and 82. So the curve will be somewhere here. Then find the area. So the area now would be actually that will be entirely covered in this thing. So that will make sense there. Let me think about it. Okay. So that still will be 50%. Given null hypothesis is wrong. So you will do 85 minus 85. So that will be 0. So 50% will be beta, which doesn't make sense here. Probability of, okay, so what does that say? Probability of accepting null hypothesis given null hypothesis is wrong. So yeah, so it still makes sense. So there is nothing, if null hypothesis indeed is wrong, okay, yeah, so and in alternate hypothesis, if alternate hypothesis is true, the probability that an alternate hypothesis is 85 itself, which is actually which is where you are accepting already. So it doesn't make sense. It has, you have already accepted it now. So it doesn't make sense. That's more of a hypothetical thing there. So, but yeah, I'll think a bit more about that. I mean, it doesn't. Yeah, but 50% of making an error in accepting null hypothesis given it is false. So null hypothesis, when 85% people are getting to null hypothesis is not wrong also. You are actually accepting it correctly. So yeah, I'll just think about it to explain it a bit more. Let's not spend time on that. But the idea is here. Okay. Yeah. 85. If 86%, no, why 85? Suppose 86% people got cured. And then you have accepted the whole thing anyway. So that's part of your 1 minus alpha there. So if it is close to that thing, you are part of your correct decisions anyway. Only when you are rejecting it. So now 84 if you say, I have rejected it, what is the probability? So let me just work it out and then come back to that. But without confusing any more on that, alpha, beta now clear. Okay, so hypothesis testing is done. So prisoner is on trial and just for fun. Jury's task is to assume that the accused is innocent. That's what we say. Not guilty till proven guilty. So there is a hypothesis being made there. So what is the null hypothesis? Prisoner is not guilty. That is the null hypothesis, not guilty. Alternate hypothesis? Guilty. Okay. If you have enough evidence, you find them guilty. Okay. So, what are the possible ways the jury will come to an incorrect decision? Not statistically out there in English.
He is guilty.
No, just two pause. No, what are the mistakes you will make? Exactly. The prisoner is guilty, but you find him innocent. The other one, prisoner is innocent, you find him guilty. Two mistakes you will make. No? If the prisoner is innocent and you find him innocent, good. If the prisoner is guilty and you find him guilty, even better. So this, which one is type 1 and which one is type 2? This is where I ask. If I ask you which one is type 1, type 2, the first thing you have to think of is, what is the goal here? What is the null hypothesis? Null hypothesis is not guilty, they're innocent. So if null hypothesis is guilty, so in your welcome, null hypothesis is guilty, you are rejecting, you are finding him innocent. So you are rejecting the null hypothesis. Rejecting the null hypothesis is you find him innocent. No? Null hypothesis is innocent. Rejecting the null hypothesis, you are finding him guilty. Okay. So that is type 1 error. No? Rejecting when you should be accepting. So finding him innocent, finding him guilty when he is actually innocent. Finding him guilty given he is innocent, that is type 1. False positive, yes, false positive. Finding him guilty. Guilty is positive. Okay, finding him guilty type. Okay, so the other one is type 2. Okay. Finding him innocent. So null hypothesis is 2. I am finding him innocent. I am accepting null hypothesis. But null hypothesis actually is wrong. The person is really guilty. The person has committed fraud or murder or whatever. And I am saying he is innocent. That's type 2. False negative. What is the power of the test? That is online Zappa. Finding guilty when he is guilty. That's why everyone is working hard now, trying to get evidence. Something is there already. He is being, there is something you are trying to prove that he is guilty. You have got someone. Who will come to mind? Some criminal recently. Anybody in mind? Huh? Vijay Mallya. Vijay Mallya, the financial things are okay. Okay, so Vijay Mallya is there and we don't know the truth right now. We don't know the truth. We go by what the media tells us and whatever is happening. But let's say we don't know the truth. We all may know the truth, but let's say we don't know the truth. And then the jury finds him guilty that he has committed fraud. So jury is rejecting the null hypothesis that he is innocent. What if he is really innocent? I am actually finding him to be a fraud. That's type 1 error. But if he is really a fraud, and I am able to prove he is a fraud, or he has committed a fraud, that's the power of the test. No? To be able to prove is the most difficult thing actually. To prove guilty is the difficult part. Okay, so that's the part that in this kind of situation proving innocent is also difficult, but that's fine. The power of the test, rejecting the null hypothesis when the null hypothesis agreed is wrong. Okay, in this case. Okay, so you are pregnant, is that a false positive or a false negative? False positive, at least in this case, the good thing is the positive thing also. Pregnant is positive, okay? Mostly. So, you are pregnant, so this is false positive, assuming we know the truth. Okay? Yeah. And in this case, you are not pregnant, so not negative, false negative. she is indeed pregnant. So which one is type 1, which one is type 2? First one is type 1 error. Okay, so rejecting the null hypothesis, the null hypothesis indeed is true. Okay, so it is not pregnant, but yeah. So that now you will understand type 1, type 2 error. Okay, keep this image in mind. Sometime back it was circulating in WhatsApp, so I immediately saved it. Okay. Finally, I just prepared this slide yesterday. So just again to emphasize that confidence intervals and hypothesis testing, one and the same thing, two ways of doing the same thing, not changing anything at all. We will do a lot of examples going forward with various types of testing, and I will show you both the outputs and how the decisions are made. Next week when we get to linear regression, I will show you the same thing there as well. So let's say this is my bell curve. This is the mean I can draw. There is this gray area. Confidence interval. What is confidence? What confidence interval is this? How much? 95. Plus minus 2 sigma. 95% confidence interval. Okay. So what does that imply? 95% confidence interval. That the true population parameter, when I say parameter, it will be mean, variance, whatever. So, let's say true population mean will lie in this range, within plus minus 2 standard errors of wherever the sample is. So, 95% of the samples, all the samples in this region, they will contain the true population value within plus minus 2 standard errors. Or the sample is within plus minus 2 standard errors of the population. Same thing like we did for apples example. Okay, so population parameter will lie somewhere in this region. If the sample is in this region, we have seen that if a sample is in this gray zone or in this gray zone, that sample mean plus minus 2 standard errors, the sample mean plus minus 2 standard errors will not contain the true population value in that range. So for these samples, the 5% samples, 2.5% sample here and 2.5% samples, the true population parameter, population mean will not be in the range that they will tell me. The true value is not going to be in that range that these samples will tell me. Any of these 95% samples, if the sample is here, plus minus 2 standard errors, well, this thing is included in that zone. So, population mean will be in that range. Okay, that's the confidence interval view of taking a look at that. Hypothesis testing. And I am doing 5% significance level. So this is 5%, 2.5% here, 2.5% here. The way we are doing the test, what we are saying, if a sample falls in this zone or in this zone, then I reject the null hypothesis that the population mean is here. And population mean here, I am willing to accept anything up to here and here is acceptable value for the population mean. I am saying that I reject the null hypothesis as this. If my sample falls here, I do the same thing here. If my sample falls here, this is not included in that plus minus 2 standard errors. Same thing. In one thing, I am giving this range. In the other thing, I am checking the p value and I am saying, well, it's not possible. Confidence interval also, if my sample is here, the plus minus 2 errors, it will say population mean is not possible. This is not the possible population mean. Population mean cannot be that value, is what it's telling me. If I got a sample here, what will I say? My population mean will be this value minus plus 2 standard errors. Population mean will be somewhere here, which is the same as saying this is not possible. Same thing. Both of them do the same thing. So we will see in examples going forward, when I get a confidence interval, if the population mean, if that value is included in that thing, the p value also will be more than 0.05. It will not be here. That means the sample is lying somewhere here, in this region. If the sample is lying in this region, the area to the left of that will be more than your significance level. Okay. The area to the left is 2.5 here. If I have a sample here, the area will be more than that. P value more than that.